Good morning or afternoon. My name is Justin Hammonds. I'm the Mitigation Liaison for the Regulatory Division of the Savannah District, U.S. Army Corps of Engineers. Today, my presentation is entitled The Savannah District's 2018 Standard Operating Procedure for Compensatory Mitigation. I thought it'd be good to start off with a little background in regards to the 2018 SOP and how we got here. Up until 2018, the Savannah District had utilized the 2004 SOP to calculate both debits and credits to aquatic resources associated with impacts and mitigation. This 2004 SOP is best described as an activity-based approach for both debits and credits, with the underlying goal of trying to achieve a compensation ratio of 2-to-1. When the 2008 Mitigation Rule was implemented, one of the tenets was encouraging districts and district engineers to use a functional or conditional based approach to calculate debits and credits moving forward. As a result of that, in 2012, Savannah District started our own efforts to develop a wetland and stream functional assessment for both impacts and mitigation. Finally, in 2018, with the help of EPA Region 4, we developed and published our 2018 Standard Operating Procedure for Compensatory Mitigation. The underlying goals of the 2018 SOP were twofold. One, to develop a functional or conditional based approach for stream and wetland credit assessment for both impacts and mitigation. And two, to develop a functional based classification for credit types to ensure in-kind replacement as compared to the 2004 generic credit types, which were wetland and stream. The 2018 SOP is made up of essentially 4 parts. The first part is a qualitative assessment for impacts, which we've broken down based upon aquatic resource type. We've created assessments for streams related to the Piedmont, Ridge and Valley, and Blue Ridge, and for the coastal plain. Secondarily, we've created wetland qualitative assessment forms for impacts based upon the riverine, lacustrine fringe, and freshwater tidal resources, also for non-riverine resources, and finally for saltwater tidal resources. Following the qualitative assessment, filling out the qualitative assessment, practitioner would be able to fill out the qualitative worksheet for adverse impacts, and these are based upon stream and wetland resource types. Thirdly, we've created functional assessments for mitigation actions to include the Interim Stream Quantification Tool for streams and the Freshwater Wetland Hydrogeomorphic methodology for wetlands. Lastly, we've created new wetland and stream credit types for the marketplace. Majority of the rest of my presentation is going to focus in on the last 2 bullets of the previous slide, focusing in on the development of our functional assessment methodologies and our credit types. The first functional assessment methodology that I would like to spend time describing is the Georgia Interim Stream Quantification Tool. Interestingly enough, we refer to this fondly as SQT Lite. The framework for our stream quantification tool comes from the stream pyramid framework that was prepared by Stream Mechanics. Within this stream pyramid concept, there are 5 levels of functions which build upon each other, starting with hydrology, then transitioning to hydraulics, then geomorphology, physical chemistry, and then lastly, the top of the pyramid is biology. For the purposes of our stream quantification tool, we focused on 3 specific levels of this pyramid in which to focus functional lift, to include hydraulics, geomorphology, and biology. The North Carolina Stream Quantification Tool was the first stream quantification tool prepared for use within the country and was the template for which we looked to develop the Georgia Interim SQT. As you can see on the far left-hand side of this particular table includes the functional category or pyramid step to include hydrology, hydraulics, geomorphology, physical chemistry, and biology. Also to include all the function-based parameters or metrics / variables that would be measured via measurement method to calculate this SQT. This would be a full SQT as it relates to all the different levels of the pyramid. However, for Georgia, we decided to move away from a full SQT because we were looking just to use the SQT as it relates to generating mitigation credit associated with stream restoration, enhancement, and preservation activities. So again, we focused in on these 3 steps to include hydraulics, geomorphology, and biology. And specifically, we're looking at floodplain connectivity and measuring bank height ratio and entrenchment ratio, riparian vegetation, looking at the left and right riparian buffer, bed form characteristics to include pool-to-pool spacing, percent riffle, and the large woody debris index, and then also a subset of macroinvertebrates. And this was specific in this initial SQT to the Piedmont and Blue Ridge Level 3 ecoregions to include EPT taxa richness, proportion Klinger taxa richness, proportion Strutter taxa richness, and proportion Burrower taxa richness. And below are some screenshots of the original performance curves associated with a metric from each one of these functional categories. As it relates to the wetland functional assessment, we looked to the HGM approach to influence and inform us on how to develop a functional assessment for wetlands. And we ended up developing the Georgia Interim Freshwater Wetland Hydrogeomorphic Workbook and Manual. Our HGM was largely influenced by the development of the regional guidebook for applying hydrogeomorphic approach to assessing wetlands functions of forested wetlands in the alluvial valleys of the coastal plain of the Southeast United States, developed by the Corps of Engineers Engineering Research and Development Center in 2013. And as part of this particular guidebook, ERDIC focused in on a number of different variables to assess functions, to include 5 that we have moved into our HGM or utilized for our HGM to include canopy tree diameter, sapling shrub cover, ground vegetation cover, vegetative composition and diversity, and woody debris. For the Georgia Interim Freshwater Wetland HGM, we settled on 5 specific variables to assess wetland function, to include a saturation threshold, looking at soil saturation within the growing season during normal conditions, vegetative composition, looking at the dominant vegetation composition of the wetland. We also looked at vegetative structure, looking at the dominant vegetative structure of the wetland. We also borrowed directly from the alluvial HGM guidebook for the coastal plain, looking at woody debris and woody debris loading within the wetland. And lastly, was there an upland buffer for that specific wetland? I did want to talk a little bit about our resource credit types that we have implemented with the 2018 SOP. The first set of resource types that I'd like to talk about are our stream resource credit types. Previous, in the 2004 SOP, we had generic stream credit types. And with the 2018 SOP, we proposed and implemented 3 new credit types to replace that generic credit type, to include ephemeral and intermittent streams as the first, perennial streams that are less than 3 square miles in drainage area, and the third being perennial streams that are greater than 3 square miles in drainage area size. And these stream credit types were stratified based upon the range of functions that have been outlined in the stream continuum model. Within the 2018 SOP, we also revised our wetland resource credit types. Our new wetland credit types are largely based upon the HGM wetland classification system, which looks at a 3-part classification to include looking at dominant water source, landscape position, and dominant hydrodynamics of the wetland. For the most part, the wetland credit types that we have developed are collapsed into categories that are based upon dominant water source, to include freshwater tidal wetlands, which are supported by that tidal flow, but not saltwater tidal wetlands, which again are dominated by that ebb and flow of the tide. Riverine and lacustrine fringe, which are associated with that overbank or backing up of riverine flows. Slope wetlands, which are that hill slope discharge, and depressional and flat wetlands, which are generally characterized with precipitation-driven hydrology. For 2021, we anticipate some changes to the 2018 SOP. And to start off, I'd like to talk about some of the changes that we are working on within the 2021 Georgia Stream Quantification Tool. Specifically, since we last implemented the 2018 SQT, we've been trying to do more regionalization by collecting and or using adjacent state data, real data, to recalibrate performance curves. And specifically, the curves that we have been working on are pool-to-pool spacing, percent riffle, large woody debris index, and macroinvertebrates. And as it relates to pool-to-pool spacing, What we are seeing within our analysis of regionalized data is that we will be stratifying performance based upon the percent of the channel slope. And you can see here on this particular curve where less than 3% will be on one curve and greater than or equal to 3% will be on another curve. And this is all based upon the analysis of real data that we've been able to collect either here in state or from nearby states. The second being percent riffle, where we are stratifying performance curves based upon different ecoregions and differences as it relates to percent riffle in those ecoregions. And as you can see in this particular curve, the blue is for the southeastern coastal plain, and the orange curve is for the Piedmont, Blue Ridge, and Ridge and Valley. As it relates to large woody debris, again, we have two separate curves that we are looking to implement to stratify the differences in large woody debris across our streams. And specifically, the blue curve on this graph is focusing in on the Piedmont, the Ridge and Valley, and those Blue Ridge streams that are less than 3%. And it just so happens that the analysis of data has also collapsed those streams within the coastal plain and Blue Ridge streams for large woody debris that are greater than or equal to 3%. And then last but not least, we've done a tremendous amount of work as it relates to macroinvertebrates to include collecting a whole data set of macroinvertebrate data in our own coastal plain and looking at specific habits and trophic levels of macroinvertebrates to find which metrics were significant to be able to show a change in performance and function. And as you can see, we've got different curves for each one of these ecoregions on the left-hand side. We're also proposing some revisions to our 2021 Georgia HGM assessment methodology for wetlands. Specifically, one of the concerns that we've heard from practitioners since the implementation of the original 2018 HGM is in regards to the saturation threshold variable, in that we have an upward and downward arm to the performance curve, and there has been some concerns in regards to wetter hydrology being viewed as more negative as it relates to performance, especially when we may have scenarios where wetter hydrology is natural and vegetation is not showing any stress from that greater hydrology for the target wetland structure, wetland vegetative structure, and wetland vegetation composition. And so we have looked to add a additional methodology that would allow for wetter hydrology if vegetation was showing that it was thriving and functioning at a very high level. Secondly, within the Georgia HGM, we're talking about making this a forested only methodology, where previously we had included the assessment ability to, or the ability to assess herbaceous and sapling shrub dominant vegetation. And from our perspective, that is not the target that we're shooting for in most of our inland freshwater wetland projects. And so the proposal is to focus in more closely on that canopy or tree structure within this HGM, and we would be moving from the big 3 tree assessment to the biggest 15 tree assessment within a 10th acre plot, and also recalibrate the performance curve to our draft performance standard target, which focuses in on 3-inch DBH at final performance. We do anticipate that there will be a change in our mitigation credit types here in 2021, specifically as it relates to stream credits. As a result of the Navigable Waters Protection Rule and the implementation of that rule, we are proposing to change the ephemeral and intermittent stream credit type to non-perennial stream credit type. And that concludes my presentation for today. I want to thank you all and hope to have further discussion during our Q&A a little bit later. Bye-bye.